Hello Dev, welcome to 4devs. In this new video demo by the 4devs.com development team, we will see a unified data flow integrating two independent applications demonstrated in the previous videos. The first is a Spring Batch application that reads logs from a PostgreSQL database and replicates them to a Kafka topic. Each piece of data is sent as a message to the Kafka topic using a producer configured in a Spring Batch job step. The second application is similar. The Spring Batch job sets up a step with a consumer for messages written by the first application in the same Kafka topic. Subsequently, the consume messages will be written into MongoDB. For this demo, we have unified these two applications. We integrated both steps into a single Spring Batch job to achieve a monolithic design of the application. Our app will function as a bridge to share information between our databases. And thanks to Kafka, we have created a complete data flow, a bridge between two databases with completely different schemas. In this case, PostgreSQL uses a relational data model and MongoDB is non-relational. To recreate this scenario, you must meet some requirements. Have Java 11 development kit, a code editor, in this case IntelliJ IDEA, Git and GitHub, PostgreSQL with the example database that we leave you in the GitHub repository, as well as Apache Kafka. If you need support installing Kafka, then check out the step-by-step installation guide at 4devs.com. And finally, you will need MongoDB with a database and an empty collection where the data from PostgreSQL will be replicated. Now, let's go to the 4devs repositories on github.com and clone the Spring Batch PGSQL to Kafka to MongoDB repository directly from the IntelliJ IDEA code editor. We cannot run the Spring Batch application without first starting up Zookeeper and Kafka server. Once this is done, run the Spring Batch application and keep an eye on the logs in the editor console. To check that everything worked correctly, let's ensure all data has been transferred to the MongoDB collection. If the data is there, we can confirm that our application works as expected. Now, with the foundation we have established, there are several paths to consider for scaling our application to the next level. To scale, the project could be migrated to a cloud infrastructure, such as AWS or Google Cloud, to handle increasing data volumes and take advantage of its scalability. We could also be decomposing the application into microservices. This architecture allows for agile updates and scaling. Additional architecture is ideal for e-commerce systems that require real-time inventory synchronization or for big data analysis, providing insights from large volumes of information. We could integrate monitoring tools like Prometheus and Grafana to observe the performance and health of our application in real time, enabling us to react quickly to any incidents. An application like this also facilitates data migration between different types of databases, minimizing downtime and maintaining data integrity. Remember, this is just the beginning. I encourage you to experiment, adjust, and build on the project we have started today. Don't forget to visit 4devs.com for more resources, researches, guides, and community support. And if this video has been useful to you, consider subscribing and sharing it with other devs. Your support helps us create more quality content. Until next time, be well, dev.